Okay, welcome to our weekly hackathon Q&A session. Thanks for joining. Thank you for your time. If you have any questions about MicroStream, so you can ask the architects. Here are the guys who write the code. So don't be shy. And you can use your microphone, you can use your chat, but we would prefer a little bit of discussion, would be nice. So if you have any questions, please go ahead.
Yeah, so hi, I'm Michael. First,
Hi,
should
Michael.
I continue in English or should we switch to German? Or should we stay in English for recording purpose?
Yes, it would be better to do it in English if you don't mind.
Okay, so yeah, I'm Michael. I'm working for a local company in Weiden too, with Weiden. And yeah, I'm following MicroStream now for almost 2 years. When you gave your first talk at DEF Camp, if you remember, Marcus.
Right, great.
Yeah. And I'm still looking for a use case where I can use it. And so yeah, the hackathon is a great idea. Yeah. So first, thank you. But I got questions. I have to say I never tried MicroStream until now by myself. I just looked at your examples all the time. But for me, so one thing I got from your talk today is there is some kind of lazy. I'm not sure if I got it correctly, but it's so let's say I have a service which has like 1 gigabyte of memory available, but the data is like much more, like let's say simple 2 gigabytes. So is it possible to use MicroStream for that case, or is MicroStream only usable if I have exactly or more memory available to my service as the data has?
You can use it with a lot more data than your RAM is. That's exactly what the lazy references are for. Everything which is not lazy is implicit eager. So everything is loaded into RAM until the lazy points. And the lazy points are loaded into the RAM when you call the get method of the lazy reference, and that's it. And you can control which data is loaded into RAM. You can unload the lazy references again. So it's removed from memory, but it's kept in a storage, so you don't lose your data. And you don't have to worry about out of memory errors or memory overflows, because a lazy reference manager, which runs in the background, clears the lazy references automatically. You can define predicates or rules how the lazy references are going to be cleared. For example, references which haven't been touched for a while, or the biggest objects and stuff like that, or memory quotas. If your memory is at 80 or 90%, the manager goes more aggressively and clears your references. This is configured per default. You can modify it, of course. But basically, you can manage which data is loaded in your RAM, and you don't have to worry about too much for memory overflows, because the engine does it automatically in the background.
Okay, yeah, this would be my next question, if I have to worry about out of memory exceptions or not. So yeah, thanks for your answer. And so this brings me to another point. When let's take the book example. When let's say I have a set of books which is 2 gigabytes, and yeah, my service is just 1 gigabyte of RAM available of memory. So and I want to find one book by ID, be all correctly handled. I do not have to think about any, yeah, as you said, out of memory exceptions or something like this.
Yeah, the best practice for that case is to to use maps. Basically, you have to split your big collections into chunks of data. Basically, you can design it for your business needs. For example, with purchases, you have a map where you can use segments for every business year. So just purchases for every year are loaded simultaneously in the memory, or even month or stuff like that. So yeah, the application design, we design the applications in a way we have the hot data always in memory, and archived data which is not accessed very often. It's in different collections, and basically your object model is designed to your business needs. So for purchases is a good way to use dates to segment your data, or you can use letters, customers which start with letter A or in a different collection, as a simple example. And that's the fastest way to navigate through your object graph as well then. So you say, I have the purchases of a customer in a bookstore demo. The purchases are held in different collections, for example, with customers as key or shops as key, and in a key in a map, and the value of the map is a list again. The objects are referenced multiple times, but you don't have to worry about duplicated data because only the references are stored duplicated, and the object is just a singleton. For example, you have a purchase which is referenced in multiple collections. The purchase objects only exist once, but the references are stored multiple times, and then you can access your object graph depending on the starting point. For example, you want to load all purchases of a certain customer, just call the get method of your customer map, or you want all purchases of a certain business year, then you call the get method of this map, for example. And the design of the bookstore demo is exactly done like that.
Okay, so I have to maintain some kind of indices my way. So I have to create them like you said, you structure the purchases by year, something like that. Okay,
exactly.
But how should I design it with a book? Like I have to find it by ID. Okay, I could put the first 100,000 books in the first map or something like this. Yeah, that will work. Okay, I get it. Yeah.
I think so. I would say handle massive data in MicroStream is nearly the same to handle it on, for example, MySQL, because in MySQL you have to think, or you have to take care about what is my core data, which is needed all the time in my application. So I would use caches for getting better performance, of course, and so then you have to decide which data is my core data, and for which data I have to use cache. And cache is kind of like the same of in-memory data. So you have to provide RAM for that cache. And this is the same in MicroStream. You have to decide which data is core data, and what is data which is used one in a week, or for example, like that. And this is kind of like the same like in the MySQL database. It's nearly the same.
Here in the purchases class, where all purchases are held, we have the yearly purchases, and there we have 3 maps. First map is indexed by shop, second one by employee, and the third one by customer. And the list is held lazily. So every time you browse through the purchases for a certain employee, for example, or for a certain customer, they are loaded once into memory and throughout later on. So the memory overflow is controlled by these lazy references, and you can access kind of like an index in a database. You just say, give me all purchases of a customer. It's a call, a simple get, and your purchases are loaded into memory. For books, we have a different approach with a lot of maps as well. For example, the ID of the book is the ISBN. So we have a map with ISBN to book or author to list of books and this stuff like that. For the
especially
simple,
for books, I think there is a good approach to use a key for the first letter of the book name. For example, if it starts with an A, so you use A as key value for the map, and all books starting with an A are in the list lazy loaded. So I think that's a good solution for books.
or logical keys, if you will. You don't have you do not use auto-incremented numeric keys like in databases. You just use customer numbers or ISBNs for books, because every entity normally has a certain identifier in the data itself, and you can use the ISBN as a key in a map, and it's unique. For example, that's the way to go.
I would say it depends on your business logic. If you want to search by the name, I think it's better to provide the name as the key, for example, because the approach is to find the book by a name, so you have to know in which chunk to search for the book. I think that's a better approach. But if you want to search by ISBN, so you can create a second map and store the same books in the second map with the same reference. It doesn't matter, and you can use this this map for searching for books, for example. Different approaches.
Yeah, in the books we have a special case for full text searching, because databases do it very well. In Java, you can browse through your books and search by name with substring matches or regular expressions, or you can use Apache Lucene, for example, which is used inside the index class here. And there you have a full text search for book titles, for example, and it's maintained in this index class, which is used down here in this method. You can search by title. You just hand over your query text, and in the index, the books are searched and returned as a list. And so the index is maintained inside the Lucene index, for example, which you can combine with MicroStream to use full text search, because the Java core stuff is sufficient for most cases, but it's not very fast. If you have to compare a few thousand or millions of objects with substring matches or regular expression matches, it takes a lot of time. And therefore we use Lucene, which is used in the most search frameworks or servers. For that, it's basically a standard library in Java, which is used throughout a lot of business applications, and it's battle tested in thousands of applications.
Yeah, okay, but exactly for this example, I need all books once at a time at the memory.
No, it's maintained in the Lucene index. The index is mapped to ISBNs, for example. You can say which fields are keys in your index. In the books, it's the title and the ISBN, and the index accesses again the map, and all the found books are loaded into memory and returned in a list.
Okay, okay.
Yeah.
And also a good solution would be try it out. In our experience, you will be able to store millions of books in a small amount of RAM need. So you can store a lot of books. I'm pretty sure.
Yeah, I know, but it was just an example. So yeah.
Yeah, I know.
Okay. I got another question, but yeah. So one thing is the store operation, is this a blocking operation, or is there the actual story on this dispatched to like another thread or something like this, that it's not blocking the thread?
The store threads are running in different threads. Yeah, per storage channel, we have one thread. For example, you have 4 threads or 4 storing channels. You have 4 different folders on disk if you store on disk, and every channel writes into one separate folder with one separate thread. So the writing operations are running in parallel, but the write call itself is blocking. So you have immediate persistence. It's a volatile atomic operation. If the store returns successfully, your data has been written on disk.
Okay.
But the I/O operations are running in parallel in the background.
Okay.
Yeah.
Yeah, that's it from of me. Yeah.
Christian, I have a very difficult question for you prepared. It's
Again.
from the forum. Do you again? Do you recommend a specific database
What?
for
MicroStream?
storing? Yeah, for storing MicroStream data. Do you recommend a specific database, or I guess the question is about do you recommend MySQL? Is it better to use MySQL or Oracle NoSQL, or maybe distributed cache or a blob store? So what you would recommend?
Okay, basically I want to keep it simple, so I would suggest the file storage database.
I guess it depends on your setup, on your infrastructure. So if you're running in the cloud and stateless containers, the best way would be to store in blob stores like Amazon S3, for example, or MySQL, or in test systems, or in monolithic systems. You can write on disk as well. Yeah. We have one question in a chat. How our plans to make it open source, and when and where it will be hosted. To where, I can say it will be on GitHub. And the when isn't decided yet. There are a few decisions we have to make, but it will be published on GitHub.
This will not take too long. So we have decided to open source it, and it's only a decision about a decision of which license. So we have to decide this finally, and then we will open source the first part of MicroStream very soon.
Okay, I think I got another question. I think I have asked it before at the Dev Camp or something like this. So
Okay.
let's say the book service I have to write is like must be ultra high available. So even through deployments, it must be there. So is it possible to load balance the load to 2 services if using MicroStream, because the data is in memory? So I know if they share the same storage where the things are stored, but do they get the changes immediately, or how does it work? Or is there a recommendation for it? or can it be even used? So yeah.
So, but it's a really hard question. I would say let's ask this question with a MySQL database. It's even hard as with MicroStream. So you will need the right infrastructure to handle those complicated things like load balancing and so on. I think, or I'm pretty sure it's not basically a thing of MicroStream to handle this. So I think in most cases, the infrastructure should provide you can use REST services to store the data, maybe to a MicroStream storage node, for example. Then you can provide the data to do different applications, for example. I think there are a lot of solutions for this scenario, but I think this is not a core feature of MicroStream. But maybe Florian can answer this. We are working on a cluster at the moment for MicroStream, and I think that could be also a solution to handle those situations.
Yeah, basically, if you have two nodes running, as long as you only write with one node, you're fine. But if you want to replicate your nodes or even shard your data, there we are currently working on a automated solution where the actual storage data is held in a different service, independent from your nodes. In distributed grids, for example, or we will provide different adapters for different frameworks. And the nodes itself will interchange the object graph and distribute the object graph over a few nodes or multiple nodes. Basically, it's an advanced replication, and the sharding of the data combined, or the replication combined with the lazy loading brings the sharding within. So we will provide a replication service which can be used inside the application, and depending on what data you're loading with your lazy references, you can decide which node holds different data. For example, you have a node which handles the purchases and a different node which holds all the customer data. But they will access the same storage or a distributed storage. Or you can use a microservice architecture where every microservice has an own storage as well. And for that, we are currently working on a solution. For now, the best way is to use storages which are independent from your application nodes, so your nodes are stateless. For example, you're working on Amazon, you just store your data in a S3 bucket, for example, and if the second node is in standby and has to go to action because the first one isn't reachable anymore, it just pulls the data from the S3 buckets on demand. That's the current way we are managing high availability in projects, for example. Yeah.
Okay.
Because the nodes will fill up its cache on the application side automatically. You don't have to worry about that.
Yeah. Okay. So, and then I saw on your website you were planning, or there's some statement that you're going to provide some kind of MicroStream as a service. So just want to know your what you're planning here. So if it's okay to ask in this meeting.
Yeah, it's in test. We developed a MicroStream server, so we will be able to provide this service within an AWS infrastructure. So this we are at the moment we're testing this service or this server. Yeah, that's all I can say.
Okay. Yeah.
It's it's nearly final. Yeah, I would say,
Okay.
but we're testing at the moment.
Yeah, of course, this is secret, and this is the reason why I was muted. So sorry about that. Yeah, we expect that we can launch the storage service with one of the next few updates. I guess until maybe spring or so.
Yeah, Q1.
Yeah.
And Q1, Q2.
Testing looks good, and we want to launch it as soon as possible.
Okay.
If you have further questions, you can use our hackathon forum. We will answer the questions very fast, and or you notice your questions and wait until the next hackathon Q&A session next week. Okay, then thank you everyone for joining and for your time. Happy hacking. See you guys.